YouTubers? Today we're going to be looking at bad Bollywood movies and criticizing their physics.
The first movie we will be analyzing is titled Ambala, starring Vishal. So first, my man Vishal is just flying through the air on this truck. As you can see, this goofy dude has absolutely no regard for the laws of physics, just sitting on there, unmoved.
So first, we had to calculate the angular velocity of the car that he was sitting on. We timed the amount of time it took in the video as 1.2 seconds for one rotation. Using 1.2 times 2 pi, we can calculate his angular velocity as 7.53 radians per second. We found that the car used in the video is a Tata Mobis, which has a length of approximately 4.421 meters. Assuming that the car spins around its geometric center, Vishal's radius of movement is approximately 2.2105 meters. Now that we have this information, we can calculate his tangential velocity by multiplying the radius of movement by the rotational velocity to get 16.65 meters per second. Through our extensive research, we found that Vishal's mass is approximately 73 kilograms. So using mv squared over r, we can calculate how much force it would require to keep him in his path of motion. So we'll do 73 times 16.65 squared over 2.2105, and we find that the force required is 9,155 newtons. Now that we have this, we can use the equation to find the coefficient of static friction, which is F equals the normal force times the coefficient of static friction. Because we know force, which is 9,155, we can set that equal to Vishal's weight, which is 73, times the force of gravity, which is 9.8, times the coefficient of static friction. Then once we solve for the coefficient, we find that it is 12.797. This proves that the scene in the movie would be completely impossible because the normal coefficient of friction between clothing and aluminum is around 0.43.
Alright, so for this next clip, this absolute unit of a man thinks that he can stop a train with one punch. Let's see what happens to this goofy looking dude.
Okay, so for this clip, we can assume that each train car is about 36,287.4 kilograms. And from the video, we can see that there's about 100 of them. And we can also assume that each train engine is about 120,000 kilograms. And from the video, we can see only one of them. So when you do 100 times this plus 1 times this, we get the mass of train is equal to 3,748,770 kilograms. And this goofy looking dude is trying to stop all that. And so when you look it up online, you can find out that the average speed for a locomotive is about 13.4112 meters per second. So he's stopping a 3 million kilogram train that's going 13 meters per second. So we can use law of conservation of momentum to find that m1 v1 plus m2 v2 equals m1 v1 final plus m2 v2 final. So when we calculate 3,748,000. And then we're just equaling it to 0 because because the guy was at rest. So we set that equal to, and then, the mass of human is around 70 kilograms. So that's our assumption for the guy. Equals 70 times velocity of the man final plus, and then the velocity of the train is about 0 after getting punched by the guy. So it's just 0. So you multiply these two together and then you divide by 70 to get that the man's final velocity is equal to about 718,221.5 meters per second.
Crap!
And that's about equal to 1,606,614.62 miles per hour. So this goofy looking dude would create a really, really big sonic boom.